I really like HTTP files, and in fact, I think we could take them a step further and turn them into a really awesome integration test tool. So if you're unfamiliar with an HTTP file, let me pull one up for you. So I have some in my Sovereign Tides server. So here's one for creating a player, for example, and this is it. So it's really lightweight. You can see here there's some information about the request. So this one's called create a player. So this could be like a test name in our case. And we could perform a post request to this endpoint, specify some headers, specify a body, and then if we really wanted to take this way beyond what HTTP files can do, we could add assertions in too. And I think that's something I want to do. We're not going to knock it all out today. That's quite a big project. But I think the plan today is just to write a parser for HTTP files in Zig. So let's do that. I've got a project here called HTTP spec. I just started this and then I realized, hey, this would be a great thing to do a video on. So none of the files have changed yet. It's with Zig 0.14.0. So we're kicking it off there. And yeah, let's get started. Since we're building an executable, we don't necessarily need our root.zig. Oops. Oh my gosh, twice. So we don't need our root.zig. And then we can update our build.zig to remove references to root. So we have this right here, and I can't read those numbers. I think it's 8. Okay, and then we can delete these. We don't need to add a static library based on that, so we can delete that. Delete that. We still have our executable. We still have our main.zig reference. We don't need this for testing because that library doesn't exist anymore. Can remove this line. And then we can come down here and say that test step does not depend on that. Okay, cool. Trim the fat on our build.zig. And let's go ahead and open main.zig. And we probably actually don't want to start with this. So instead, I'm going to create a new file. It'll be, we'll call it, where do we want to put this? Let's do, well, first, let me make this a little bigger for you. And we can do maker, something like source, HTTP file. And then we can vim source HTTP file parser.zig. And we're essentially going to go ahead and build out what that file looks like in our case. So we have standard library that we're going to go ahead and import. I'm just going to go ahead and make a couple references here to allocator, which is going to be standard mem allocator, so I don't have to type that so much because I have a hunch we're going to use it quite a bit. And then same with array list. We're going to keep an array list of requests. So yeah, let's go ahead and grab a handle on standard array list as well. Okay. So we have to support all the different HTTP methods. So we're going to go ahead and create an enum for that. So it'll be pub const HTTP method. It's an enum. And we want to support get, post, put, delete. This would be a really great use case for Copilot because it could pick up on this pattern and I wouldn't have to type all this, but that's okay. Options, trace, connect. I think that's all of them. And I guess technically we have an unknown. Okay, so we need to, looking at our spec here again. So I've got the HTTP, I'm not sure if this is the actual spec or not, but this is a pretty good source of truth for information on HTTP files. So, okay, yeah, so options, get, head, post, put, patch, delete, trace, connect. I think that covers them. And you can see here that this is what that first line looks like, right? So it's an HTTP verb, and then it's a URL and an optional HTTP version. So in our case, we might skip the HTTP version for now. Actually, I don't know why we would. We can implement that as well. I'm just trying to make sure that this doesn't end up being a 4-hour video. Okay, so we need to take this and get it from a string value. There might be a built-in for this. I'm going to just take a look and see if there is one. Okay, I'm not seeing one, and nothing is coming to mind. So we'll just write the code to do that. We can always end up refactoring it and cleaning it up if it turns out that there is a built-in to support this. So there's enum from int, ag name, converts an enum value to a string literal representation of the name. That's the opposite of what we need. Oh, okay. Well, no worries. So we'll just go ahead and implement this. So this should be something like method string const u8, and it's going to return an HTTP method. So this will be, let's go ahead and uppercase whatever we have. It should be uppercase by the spec, I believe, but we can support that out of the box. That's not something that we need to worry too much about. So this will be method string, and then it'll be, this is the output. Okay. Yeah, okay. So this will be method string. We'll store the output in method string, and then the output that we're converting is method string. That works out really well for us because the buffer that we're working with is going to be the same size as the buffer that we are getting out. So yeah, that works out really well. What does this return? Interesting. So this goes through, converts all the characters for output, and then returns it as well. Okay, we need to essentially do some checks to see if these are equal. So we can do if standard mem equal u8, this is method upper, and then if it's equal to get, then we want to return dot get. And boy, howdy, we are going to do this a lot. So I'm just going to go ahead and add a couple of these, and then we'll come in and change the pieces that need to be changed. Okay. We need one more case where we return unknown. So if we hit the bottom, we have essentially an unknown HTTP method. Okay, feel pretty good about that. I think that takes care of our HTTP method piece. We need a struct for headers. So I'm going to create a header struct here. This is going to have a name. It's going to be a slice of const u8, and a value will be the same. Okay, so let's go ahead and write a struct for the HTTP request. This will be the big one. So we have a struct here. It's going to have a method, which is an HTTP method. That's what we called it. It's going to have a URL. It'll only have one per request. It will have headers. This will be an array list of header, and it can have multiple headers. And then it will have maybe a body. We need to go ahead and initialize this. So I'm going to initialize this with an allocator, and it will return an HTTP request. Method is unknown. URL is empty. Headers is array list of header.init against the allocator. And then the body will be null. And that'll be our default initialized value here. We can go ahead and create a dinit method. So self is going to be a pointer to an HTTP request, returns void, and self.headers.dinit. Add our missing semicolons that we are forgetting. Okay, feel pretty good about this struct. That's the request. So let's go ahead and create a parser as well. So we have pub const http parser. This is also going to be a struct, and it's going to take in an allocator. We'll go ahead and create our init method. Again, this is going to receive an allocator, and it's going to return an http parser. So we can return allocator is equal to allocator, lowercase allocator. Okay, let's add some methods onto the struct. So we have pub fun. We're going to parse a file, and this is going to get a reference to an HTTP parser. It's going to get a file path, and this is going to return, and this is going to be a const u8. We're going to return an error union with an array list, and the type for that array list is going to be an HTTP request. Okay, let's go ahead and try to get the file. So standard fs current working directory dot open file, not open directory. Open file. Pass in our file path there, and I don't think we need any specific flags. Defer file close, and then let's get the contents of the file. We can try file read. I was expecting autocomplete to come in and help me out here. I think this is going to be read to end alloc. And we'll pass in an allocator. And then we need to pass in the maximum amount of bytes for it to read. So we're just going to pass in max int usize. Okay, weird. I guess the LSP was having some issues with that, but it seems to be fine now. Let's defer self.allocator.free file content. And then we can return try self.parseContent file content. Okay. We need to write this parse content method. So let's do pub fun parse content. It's going to get a pointer to an HTTP parser. It's going to get content. And it's going to return an array list of HTTP requests, just like before. In our requests here, it's going to be mutable, so it's going to be an array list of HTTP requests. We're going to initialize that with self.allocator, if I can type correctly. And then we're going to create an error defer. We're going to defer an entire block. And this is a pretty common pattern when working with array lists, but if something goes wrong, we need to clear up all the memory that we have. Oh, don't know what happened there. We need to clear up all the memory that we have allocated for this array list. So we'll say request.dinit and then requests.dinit. So we'll go through every single request, deinitialize those, and then we will deinitialize the array list of requests. Okay, we're going to create something to hold our current request. So http request.init self.allocator error defer. Same thing here. We're going to do current request.dinit. So if something goes wrong, we just want to go ahead and deinitialize that at the end of the scope. Okay, let's get our lines. So we'll do standard mem split u8 content, and then new line. Split is deprecated, right? So let's go to definition. I'm pretty sure we want split scalar. Deprecated, use split sequence, split any, split scalar. Delimiters. Yeah, I think we do want split scalar. So let's change this to split scalar. That gives us an iterator. We'll do something like while lines.next line. We probably need to keep more state here. So let's keep an index. This is going to be a use size. We need a couple of Booleans to keep track of whether we are in headers and whether we are in the body. Not sure how else we'd approach that, so this seems like the simplest path forward. And then we essentially need a buffer to hold the body as well. So this will be another array list. How fun. This one will be a U8 for the type, and then we'll init that with self.allocator. Again, defer, body buffer, dinit, so clean that up at the end of the scope. Okay, this feels like we have enough to kind of keep track of things. So the very first thing we're going to do is increment our line index by 1. Goodness. We're going to trim the line. So trimmed line is equal to something like standard mem trim U8 line. We want spaces, which is standard ASCII spaces, white space, white space. Okay. So with HTTP files, you can do comments as well. So we need to handle the case that there are comments. I don't care to parse your comments for you. I don't see any benefit in me parsing those, at least for now. So yeah, we'll just skip comments. I'm pretty sure they are either / or an octothorpe, which is fun. So with that in mind, if trimmed line dot length is equal to 0, continue. If standard mem starts with U8 trimmed line, and then our needle here is going to be the octothorpe, or standard mem starts with U8 trimmed line, and this needle will be the slashes. So if we run into this scenario, we also want to continue because those are comments, and I don't care. We don't need your comments, at least for this. I'm sure your comments are wonderful, but I don't need to parse them. We'll do another check here. If it starts with one thing, and I don't know why, U8, and we have a trim line here, and we'll check that trim line against the request delimiter up here, which is the 3 octothorpes. Yeah, right here. Contain multiple requests using lines with triple octothorpe as the delimiters. So we'll need to handle that case too. If current, if current request method is not equal to unknown. So if we're in a scenario where we find a new delimiter and the current method is known, that means we are on to a new request. We need to do a couple things here. So we'll try requests.append current request. So we'll add the current request to the requests array list. We will get a handle on a new request for current request. Allocator here. And then we know that we are not in the body, and we know that we're not in the headers. So we'll set those equal to false. I think there's one more piece we'll need to do right here. We essentially need to do like a body check, right? And make sure that if we're in the body, dupe it and clear it. Ooh, yeah, we'll come back and implement that in a second. So just before I lose my train of thought here. So we're looking at the trim line. If it's a new request delimiter and the current request is not equal to unknown, that means we have a new request and we need to support it. So at the end of this if right here, we also want to continue. Okay, that makes sense. So if we're in the body, dupe it and clear it. So if in body, and body buffer dot items dot length. Yeah, that actually looks right. Is greater than or equal to 0. Current request dot body is equal to try self dot allocator dot dupe u8, and that'll be body buffer dot items, and then we'll do body buffer dot clear retaining capacity. Let's make sure that's correct. Okay, invalidate all element pointers by setting the length to 0. Yeah, that'll work. Okay, we're on 118. I see that I have an issue on 83, so let's go figure out requests. Okay, fixed some of that. Hopefully that'll help our LSP not have issues. Okay, so we're handling the scenario where we run into a request delimiter. So we need to essentially parse the first line. So we're on the first line if we know that I was going to say the line index is 0, but that's not necessarily true because we'll keep track even if we hit a request delimiter. So we could either reset the line index, which maybe is what we should do, but I think we could also just check if we are not in the headers. So if not in headers and not, been writing too much Python, in body and current request dot method is equal to unknown. So, okay, if we're not in the headers, we're not in the body, and we don't know what we're working with, then we need to actually parse that first line and figure out what the request should be. So we're going to get some tokens here. We're going to standard mem tokenize, and we'll tokenize scalar. To be completely honest with you, I'm not entirely sure what the difference is between tokenized scalar, tokenized any, and tokenized sequence. So that's something I need to do a little bit more research into and make sure that I have a good understanding of. Same with split. So you can split scalar, split sequence, or split any, and I'm not sure when you would use one over the other. Okay, so we need to tokenize our buffer. So this will be what? Trimmed line. And our delimiter here will be space. We can get our method string by calling tokens.next because it will be the first one, or else return error.invalid request missing method. URL is going to be the same thing, so it'll be tokens.next, or else return error.invalid request missing URL. You need those things. We'll set these values on our current request. So we'll set method, and this will be equal to HTTP method. It's all coming together from string, and then we'll pass in our method string. And then let's do the same with current request for URL. But I want to dupe it. So how to explain why? The short and sweet is that we are in a flow of parsing things. And once I'm finished parsing things, I want to throw away everything that we've parsed. Some of this stuff needs to stay around, right? So for example, the thing that needs to stay around in our case is the URL. So we're going to dupe it in our allocator. Dupe with one E. It'll be a U8 and it'll be a URL. Once we've parsed this line, our first line, we're in headers from here on out. So we can say in headers is equal to true. And continue. So we're continuing, so we recycle our loop, we go to the next line, and then in this case, if we are in headers, which we will be now, if standard mem index of U8 trimmed line, colon, can I get the colon position? Yeah, I can. Okay, perfect. usize. We can get the header name by standard mem trim. Again, U8. The slice will be trimmed line from 0 to colon position. And again, we want to trim standard ASCII white space. Same with header value. So this is actually going to be the exact same thing. I probably should have just copied the line, but that's okay. Actually, it won't be the exact same. Sorry, it's close to the exact same. Our indexing on trim line is going to be different, right? So it'll be colon POS plus 1 dot dot. So we'll take everything from the colon POS plus 1 to the end. And then this will be, again, standard ASCII white space. Okay, we have those values. Let's go ahead and try current request.headers.append. This is going to be a header. So we will create a header here. And again, we're going to dupe everything here. So the name will be try self allocator dupe. This will be a U8. And the value that we want to dupe is header name. So we'll go ahead and let that dupe. And then we'll do the same thing. Oops, sorry, that needs to be a comma, not a semicolon. And then we'll do the same thing right here, which is value try self allocator dupe. Again, it'll be a U8, and then it will be header value. And don't forget our semicolons right down here. Okay, so we're going to append those if we have them. If we don't have them, okay, sorry, the positioning on that was way off. If we don't have them, then essentially we have an invalid header format, right? So we're working with headers. So let's just return error, invalid header format. So we've got that handled. Let's go ahead and add in body. I think this one actually should be relatively simple. So we're here. Let's try body buffer.append slice trimmed line. Don't call that. It's not a function. Try body buffer.append. And we're just going to append a new line here as well. Where does this if take me? I'm in an if that I'm not in an if. I'm in while lines.next. Okay, that makes sense. So by the time we get to the end of this, we are out of our while loop, and we just need to add the current request if it's not already added. So we can do current request method not equal unknown. So we have one. We're essentially using this method check to see if it's equal to unknown or not as a way to determine if we actually have a request or not, since there's not a scenario where we would be parsing a method into unknown, and it's just the default value from when we initialize it at the beginning. So let's do an if in body, and body buffer items length is greater than or equal to, or sorry, just greater than 0, not greater than or equal to 0. Current request.body, again, try self allocator dupe U8 body buffer, and then try requests.append current request. And then down here, we just want to return requests. Okay, I think this about covers it. Okay, so I do think we're missing a scenario to transition to the in-body state. So I'm just going to take a look at this and see what that looks like on our end. Okay, perfect. There is a new line here, so we can key off of that. So let's head back up to our while loop, which is up here somewhere. Yeah, right here. So we're getting our line index. We're checking the trim line, checking if the length is equal to 0, which is where we want to be. I think we just want to add a case here where if we are in headers is equal to false, and body is equal to true. I think that should take care of it. Okay, let's assume that this is working, and let's prove ourselves wrong by writing a test. So what we can do is something like test HTTP parser from string contents. I never remember what the testing allocator, there we go, testing allocator in Zig looks like. So let's see if I can get something that points to the testing allocator. Not as helpful as I was hoping. Our good friend Carl may be here to help us out. testing allocator. Perfect. Yeah, I just want an example of how to use the testing allocator. Oh, okay, that's it. So we just pass in a reference to what looks to be a global testing allocator. Okay, so we can do something like var parser is equal to http parser dot init, and this will be standard testing allocator. Const test http contents is equal to we'll do multi-line strings here. So get https:// api.example.com. There's also a spec version that we need to support, so we're not supporting that yet, so we'll come back to it. There's also a post, which is going to be something like, I don't know, it's really any header value. So I guess we don't necessarily need that, but let's do accept, and we'll do */*. Anything else? Authorization, bearer, ABC123, something like that, maybe. Blank line. And there's not necessarily a body for this one, so let's go ahead and just do the request delimiter, which is the 3 octothorpes again. And then let's do like a post to https:// api.example.com/users. We'll kind of follow the same pattern here. So we'll just do accept. And then we'll also do authorization bearer ABC123. This one gets a little different because we actually have a body. So we'll do name, John Doe, email, john@doe.com. We have a missing quote up here, and then we need to close that out. So that should take care of that. So we have our HTTP contents to work with. So now we can get our requests by calling try parser.parse content test HTTP contents. I wish it would. My LSP is being very, very weird, assuming that was a function. Defer for requests.items. And this is good because this shows how this should be used, essentially indicating that, hey, by calling this, you are owning the memory that has been allocated here. So you're responsible to free it. Okay, so we get our requests. Okay, it looks like we can do standard testing expect equals. So let's do that. So let's try standard testing.expect. Oh yeah, there's quite a few options in here. Truth be told, I've not done a ton of testing in Zig yet, so kind of cool to do that. We're expecting, let's start with the method maybe. So if we do method get, and we do at tag name, request items index 0 dot method, and then we'll do the same thing here. The second one should be a post, and then we'll do the same thing here. This one should be what? https:// api.example.com. And then this is not the method. This is the URL. Same with this one. It'll be the URL, https:// api.example.com/users. We could check the header types. It's probably a good thing to do. So the key would be authorization. Oh, and one thing I need to clean up here, these shouldn't have tag names around them. So let's fix that. Okay, and well, neither should these, so let's fix that too. Okay, so instead of URL, this would be headers. And then if the accept one's not a particularly interesting case, so I'm just going to go ahead and grab the second one, and then make sure that I'm not sure why that's not working. Pretty sure we called it key. Is that correct? Take a look. Name. Okay. So we check the name there. I'm just going to go ahead and delete this one, yank this one, go to the end, paste it here. And then we're going to do the same thing here, except we're going to check the value. And this should be what? Bearer ABC123. Same thing here, but the difference this time is that we'll be working with the second request. And then we can do one more testing, expect equal, and then we're expecting 0 for request.items, 0 body length. This should be requests. And then I think the same thing here for this one, except it should not be equal. Do we have expect not equal? What do we have? We do just have expect, so let's do that. So 0 is not equal to request items index 1 body length. Okay, a lot going on here. So I am just going to run zig test and then point to the specific file, and we can resolve this. So in our parser on 92, we see that we expected type U8 and then found a pointer to a const slice of U8. So I think our issue there is since we're using the \n, I need to throw another backslash in there. Just a pretty basic mistake. Yep, so right here, let's just throw another \n in there and give this another go. Actually, this might be more information about when we would need to use split sequence versus split scalar. So I think since this is a sequence instead of a scalar byte, we need to use split sequence. So I think the same goes with where we're trimming down here. Nope, that's a single space. So, okay, I think we're good there. Let's give this another go. Array literal requires address of operator to coerce to slice type. 101. Okay, so on 101, we are missing an ampersand. And then I know for a fact we are referencing this somewhere else. A couple of spots, it looks like. And we're missing an ampersand there and an ampersand there. Give this another go. Okay, so split scalar found U8. Oh, I'm so silly. Okay, so on 133, oops. The issue here is actually not the scalar, it's that I'm not using a scalar type. So let's convert that to a single character, give that a go. Okay, it looks like similar issues here. So on 19, we have a string. Let's fix the 159 one first. That one's going to be far more simpler. So on 159, we need to convert that to a scalar type. And then on 19, expected type U8 found const U8. Okay. It's because it's a buffer that we are outputting things into, and I think I have it declared as a const. So let's fix that. So method string needs to become a variable, and then 159. So 159, 159. Let's try that again. Yep, so Okay, and then, oh yeah, method string is a const right there. Okay, so the issue here is that this is indeed a const that we're passing. This needs to be mutable. I actually, just looking at this again, I think I kind of took the wrong approach here. So I don't think I need this at all. And instead, what I can do is do standard ASCII equal ignore case. And that'll simplify a lot of this. So this becomes method string in this case. And this actually looks like a pretty good spot for a macro. So let's record Q, T. We're going to delete word, delete word, delete word. And then we're going to type method string. We're going to go down. We're going to go back, back, back. And then we're going to quit our recording. So now, yeah, it's pretty good. It's not exactly what we wanted, but looks like I went back one too many. So I need to progress forward a word. Not that you care, the random Vim shenanigans. This should solve our problem with needing that to be a mutable buffer, because we aren't putting it into an output buffer. We're just using equal ignore case. Oh, except we need to use equal ignore case, right? So same thing here. Probably the simplest approach for this, though, instead of being fancy. %s standard mem equal, convert that to standard ASCII equal ignore case. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Seems good to me. Give this another test. Okay. Another issue. Yeah, this should be, we'll do the same thing here. This is equal ignore case becomes EQL ignore case. Give that another test. And it looks like on 163, we are expecting a type of a slice of const u8, and we have an array list of u8s instead. So let's take a look at that. So I think this just needs to go from body buffer to body buffer.items. Give this another test. Getting closer. It looks like our array list aligned does not support indexing. Okay, so we're missing items there. So let's go to 205. Yep, missing it all over the place. So let's head back over here. This becomes items, items. Okay, let's give that a shot. Okay, so the body actually can be null in our case. And we're checking to see if that is equal to 0 in the case of it not existing. But I think actually what we need to do is check if it is null. So let me see if I have, do we have try standard testing expect null? So we can just do or else 0 in this case. So if we don't have one, we'll just assume that it is 0. No, that is not going to work as simple as I had expected. So let's wrap this in parentheses. Or else, something like that should be fine. Give this a run. Oh, same issue, does not support field access. And we need to remove the null type here. So what we can do again is wrap this in parentheses, use an or else, like so. Give this a test. Okay, and it looks like we actually have an index out of bounds issue. So we're indexing into 1 and we have a length of 1, which makes me think that we are not parsing our second request. I'm curious why that would be. I'm also curious if this line right here has anything to do with it. So I'm just going to remove that and give this another test and see if that changes anything. Okay, cool. It does not, which is a-okay. So we'll add that back in. Okay, so we have this case where we're checking if the trimmed line. So maybe what we do here Okay. How funny. Okay, so yeah, we have this case, right, where this totally makes sense in hindsight. So we're checking to see if the trim line starts with an octothorpe, and if it does, we continue. However, 3 octothorpes is the sign of a request delimiter. So in our case, we're prioritizing the single octothorpe over the triple octothorpe. And we can simply change that by changing the order in our code at which those are called. So let's give this another go. Zig test. Okay. One test failed, 11 errors were logged, one test leaked memory. Cool. So our tests are running successfully, which is great. We do see that there's quite a few leaks that we'll need to fix at some point. But I really just want to see the output. So testing parser.zig. Okay, so we're expecting them to be the same, but it does not appear that they are. So parser 203, let's go take a look at that. Request.items.url. I'm actually curious what that is, if not https API example.com, no extra spaces. Okay, let's, yeah, that looks like it should be correct. So let's add some debug logs up here where we are parsing the URL. So I don't think we hit the invalid request missing URL piece. So instead, what we can do here is standard debug print. Yeah, something like this. And we'll pass in the method string and the URL. Give this a run. Those leaks are going to be problematic, so they're taking up a ton of space. We should fix those sometime soon. But for now, let's try to get the test working. Okay, so we can see that it's git, and then it's https://apiexample.com. That looks like what we would expect it to be, right? So expect equal https apiexample.com. Let me just look at my tests really quick. Okay, so we are getting methods correctly. So we're getting get and post, which is good. We're also in that output, we are, you know what, let me just open up a new tab here. That'll be a little easier. Take this up, head to HTTP spec, I think is what we called it. Zig test source, HTTP file, parser. Run these tests again, and that way we don't have to keep closing Vim and coming back into Vim. It seems a little excessive. Oh, actually, okay, this is not clear at all. I think I just made some assumptions about how tests work here in Zig. So let's do standard debug print 1. Just want to double check something here. Okay, I know those are a bunch of ones, and that's not super helpful, but it's a step towards debugging just to prove something here. Oh, yeah. Okay. Okay, I went ahead and just updated the print debugs to be incrementing numbers and then also having the necessary arguments that they need. So I'm just really curious to see what is printed here or how far we get into our tests even. Okay, so maybe we are failing on the method. So what we'll do here is standard debug print. We're going to print 0, and then we're also going to print requests.items 0.method. And that needs to be wrapped in an anonymous struct. Invalid format. Let's go fix that. Why is this invalid? It's an enum, isn't it? So we need tag name. Okay, we do see 0, and then we see get, and then we see 1 and 2. I am just losing my mind because I did not add a single line break here. Okay, I've added some line breaks. Let's go take a look at those and see if that's any clearer. Did I not add as many as I thought? Oh yeah, I am missing a line break at the very beginning. Eesh. Okay, so we do see 1, 2, expected slice pointer found. Oh, okay. So This shouldn't be expect equal, right? This should be, yeah, expect equals strings. Let's try changing this. Oops. Shocked I didn't break something there. Strings, 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 strings. Wait, no, that last one shouldn't be strings. It should just be expect equal. Okay, let's give this another run. All one test passed. Okay, the great news is we have our test passing, so we are actually parsing our HTTP files like we would expect. There's so much more room to grow this, and I'll probably do this in more videos because looking at the timer on OBS, it is about an hour and 20 minutes, and I need to get some food. So maybe before I do that, though, we take a look at some of these memory leaks and see about fixing those. Okay, so GPA memory address, here's our address it leaked. We can see where it leaked. Parser.zig 150. So let's go take a look at that. So 150. Okay, so looking at this leak, it looks like on 150, we are duplicating a value, and the value that we're duplicating is, so like the dupe is never being freed. So we append this into our headers. So at some place, we have our request somewhere up here. And when we deinitialize our request, okay, we do call self.headers.dinit. Okay. So that is part of our issue, right? So we're deinitializing our array list, but we need to loop through the items in our headers and deinitialize those. In fact, I think we have quite a bit more that needs to be done given how we're duping things. So we can check here if self.url.length is greater than 0, then we need to free this. So self.allocator.free self.url. And then for self.headers.items, header, self.allocator.free header.name, self.allocator.free header.value. We probably need to do the same for body too, right? If self.body, body, self.allocator.free body, and then we can deinitialize our headers. I feel better about this. Let's give this a run and see if we have as many leaks. We won't because I don't have a allocator in our HTTP request. So let's get a handle on that as well. So we'll say allocator, keep it up here. And then we'll add our .allocator is equal to allocator. Okay, that should solve that. Come on. Okay, perfect. That was it. I'm shocked that we're not leaking more memory on a first pass for something. But here we are. So what I'm going to do is clean up these tests. These are gross. Oh, not that one. Okay. Sweet. Clean up those tests. Run this again. Zig test. Excellent. Standard debug print. Yep, remove that. We don't need that anymore. Fix that. Give this another shot. All one test passed. Great. I'm going to get init. I'm going to git commit. Let's take a look at what we're committing first. I don't need tool versions or the zig cache, so I'm going to vim.git ignore. Dot zig cache and dot tool. Oh no, I do want tool versions. I'm not sure why I was thinking I didn't want that. Okay, so we have our git ignore, tool versions, build zigs on, and our source files, which looks good to me. So let's commit initial commit for HTTP file parsing. Okay, and I'm also using the GitHub CLI here to create a new repo, push up an existing repo, local HTTP spec, Brad Seipert description, HTTP files as integration tests. I think that's a great idea. Add remote, yes. Origin's fine, yes. We don't have a README, so let's create a README HTTP spec. HTTP spec is a tool that takes HTTP files that expands upon HTTP files by adding assertions to them to be used for integration tests. HTTP spec is also intended to be a test suite runner for these extended HTTP files. More coming soon. Add README. Give this a big push. There it is. This is open source. So if you want to help contribute, I would love that. I will probably try to put out another video where we get to spec. So for example, while we do support comments and we support actually a fair amount of what needs to be parsed, we don't support variables, and those seem really useful. Should we support environment files? Probably. So that's something we'll also probably need to support. They have information about shared variables. Some of the stuff I don't know if we need to fully support, but the point here is we probably should identify what we do need to support and what we don't, and then draw a line in the sand and put that in the README to explain what we do and don't support. This is really cool too. I think this is actually like key to making those tests work. So you can pass values from one HTTP request to another within the same file, which is pretty cool. So there's a little bit of information on that. And then also figuring out how we extend the specification so that you can add assertions to these and we can parse these. And we've worked on the parser, but at some point we'll actually need to execute the tests using an HTTP client and then compare those to the assertions to tell you whether your tests have passed or not. And then growing this even farther, it might be nice to do an XML or like JUnit style test reporter type solutions. So seems like fun. Hopefully you think so too. I'd love to have you work on this with me. If you found this video helpful, don't forget, like and subscribe. You can learn more about Zig here. I don't know. I wish there were more people talking about Zig, especially on YouTube, and teaching about Zig. I don't want to say I'm your best bet for frequent content, especially since this is a part-time endeavor for me. But yeah, I think that if you do subscribe, you'll get plenty of videos on Zig and hopefully learn something along the way. So if you haven't yet, consider subscribing. Also, let me know your thoughts in the comments below. This video is very different than most of the videos that I've been putting out recently. So this was just a from start to finish, at least for today, deep dive on something. And it's, fully building it in real time with really loose notes and just trying to kind of put something together for myself. But I thought it would be really educational. So I thought it would be fun to talk about. I actually think the variable one will be really neat. Not that we are doing anything too different when we get to variables, but we'll be implementing a hash map and then using a hash map and managing the memory around that too, which seems really, really useful. I'm rambling. I should not. Come say hi in the comments. I'd love talking to every single one of you. Thanks, and have a great day.